factor. Not only just finding the greatest common factor, but also we need to factor it out as well. So we're going to be working on that today. So let's go ahead and let's take a look at this. So this is something that you just finished up with in Unit 3. So when you have something like this, remember we distributed it. So then we multiply the coefficients, so 3 times 4, which is 12. And then when you have x squared times x squared, remember you're going to add those exponents, and that's going to give you x to the 4th. So 3 times negative 3 is negative 9. X squared, now this is the same as x to the 1st. You need to remember to add those exponents and get 3. 2 times 3 is 6, and then you get x squared. Last but not least, you want to make sure your answer is in standard form. So I see that my exponents are going in descending order, so I know that it's in standard form. Same thing for this guy right here. So I'm going to do 4 times 3, which is 12. And then x cubed times x squared, I'm going to add those exponents and it gives me x to the 5th. 4 times negative 2 is negative 8. X to the 3rd times x to the 1st is going to give me x to the 4th. 4 times negative 1 is negative 4, and then I'm going to have x cubed. So I see that my exponents are going in descending order. So that right there is my final answer. So let's go ahead and let's take a look at what the greatest common factor is. So the GCF is the largest factor that can be taken out or divided out of each term. So it's the biggest number and the most amount of letters that you can take out. I always call it looking at your bank account. You don't want to overdraw your bank account. So you can't take out more than you have in each bank account. So you can't take out more than you have in each term. So that's kind of the point that the second one makes, is that a term can only be factored out if it is in each term. Okay, so let's go ahead and let's take a look at the steps. So first of all, the first step is to find the largest number that factors into each coefficient. So we're looking for the biggest number that divides each of them. Okay, you're looking for the biggest number that divides each of them. Then you want to find the largest number of each variable that you can pull out. So you want to find the smallest number of letters that you have, and then you can factor that out. For number 3, you want to divide each term by your greatest common factor, which is what we just found. Then we want to write our new polynomial multiplied by the greatest common factor. So this is actually really key. You want to make sure that you're not taking anything out of the actual problem. Okay, you don't want to just have something disappear. So if we were to do what we did on number 1 and number 2 and factor everything back in, you still should have the exact same answer. If you don't, then you did something wrong. So let's go ahead and let's take a look at this. So first thing we want to do is figure out what divides 12 and 16. So when I first start, I like to start out by writing just a list. So what goes into 12? And I like to write it as pairs. So I have 1 and 12, 2 and 6, and 3 and 4. And what goes into 16? 1 and 16, 2 and 8, 4 and 4. So now that I've made my list, I want to find the biggest number that divides both of those. And that biggest number is 4. So I can take 4 out of each term. So I'm going to go ahead and I'm just going to write that down. So then I see here that I have a squared and I have a to the 1st. So then I need to figure out what the smallest number of a's is. Well, that's going to be a to the 1st. So I can only take a to the 1st out because I can't divide that last term by anything more than a to the 1st. So then what I'm doing is I'm going to divide each of these terms by 4a. So first of all, 12 divided by 4 is 3. A squared divided by a to the 1st. Subtract those exponents and then you get a. Then 16 divided by 4 is going to give us 4. And a over a is going to cancel out. So we don't even have to write it. So this right here is our final answer for number 3. So let's take a look at number 4. We need to figure out what divides 14, 6, and negative 4, which really we can just look at 4 for right now. So for 14, I have 1 and 14, 2 and 7. For 6, 1 and 6, 2 and 3. For 4, 1 and 4, 2 and 2. So I see that the largest number that's in all 3 columns, again, it has to be in all 3 columns, is 2. So I know that I can take out a 2. So I see that I have an r in each equation, and I can only take out what is my smallest number of r's. So the most I can take out is r to the 1st power. So I can only take out r. So now what I'm going to do is I'm going to divide each of these terms by 2r. 14 divided by 2 is 7. r cubed divided by r to the first is r squared. 6 divided by 2 is 3. R squared divided by r to the first is just going to be r. And you can write to the first power if you want to, but you don't have to. And then negative 4, divided by 2 is going to be a negative 2, and r over r is going to cancel. So I just want to point out and make sure you guys notice that I always write the greatest common factor on the outside. So I don't just write what the greatest common factor is, and I don't just divide it out and write it. You need to have the greatest common factor written and what's left over after it. So let's go ahead and take a look at number 5. Now, most of you to this point are probably to the point where you can look at two numbers and know what divides them. So if you know, you can skip the part of writing out each. I'm going to do it for a couple more. So you can skip this step right here if you instantly know what divides both of those. So for 30, 1 and 30, 2 and 15, 3 and 10, and 5 and 6. So the biggest number in each column is 5. So hopefully as you get more used to this, you can just look at the numbers and know what divides each of them. So here I can take out a 5. So I notice I have an x, but I don't have an x in each term, so I can't take out an x. Same with the y. I don't have a y in each term. So all I can take out of this one is the 5. So 5 divided by 5 is just 1, and then x. You don't have to write that 1 if you don't want to. 30 divided by 5 is 6, and then we're going to have y. So you could also write this as 5 times x plus 6y. Either way, they are both correct, so whatever works for you. So taking a look at number 6, when I look at 18, 12, and 9, I instantly think of 3. 3 is what is going to divide all of those. So I'm going to write 3. I can for sure take out a 3. So then I see that there's a c in every single term. So the smallest number of c's I have is c to the first. So all I can take out is c to the first. Then I have d squared, d to the first, d to the first. So I have a d in each term, but the smallest number of d's in each term is d to the first. So all I can do is divide by d to the first. So what I'm going to do is divide each of these by 3cd. Okay, so 18 divided by 3 is 6. Well, c over c is going to cancel out. D squared divided by d to the first is just d. 12 divided by 3 is 4. C squared over c. Now I'm still going to have a c left because that's like c squared divided by c to the first. Subtract your exponents and you get c to the first. And d over d cancels out. 9 divided by 3 is 3. C over c cancels out. D over d cancels out. So we're just left with 3. So this right here is your answer for number 6. So let's take a look at number 7. So I need to figure out what divides 12, 3, and 9, and that's going to be 3. Again, if you're still not sure, go ahead and keep making these lists. There's nothing wrong with you doing that. Make sure you get help from me if you're having problems distinguishing what you need to take out. So now I see that I have x's in each of my terms. And the smallest number of x's that I have in each of the term is x squared. So that's all I can take out of each term because I don't want to overdraw my bank account. Then I say I have y to the 5th, y third, y to the 1st. So since there's a y in each term, I can take out a y, but my smallest number of y's is y to the 1st. So I can only take out one y. So now I'm going to go ahead and divide each of these terms by 3x squared y. So then 12 divided by 3 is going to give me 4. X squared over x squared is going to cancel out. Okay, negative 3 divided by 3 is just going to be negative, and I got ahead of myself. Y to the 5th divided by y to the 1st. Subtract those exponents and I'm going to get y to the 1st. Negative 3 divided by 3, you don't have to write the 1 because there's other parts of that term. So x to the 4th divided by x squared, you're going to get x squared. Y to the 3rd divided by y to the 1st is just y to the 1st. You can write the 1 on the exponent if you would like to. So the 9 divided by 3 is 3. X to the 7th divided by x squared is x to the 5th. And y over y is going to cancel out. So this right here is your final answer for number 7. Now, let's take a look at number 8. So when I take a look, I have 3, 2, and 1. Well, nothing divides 3, 2, and 1 except 1. Then I don't have an x in that last term, so I can't take out an x at all. So all I can do, so my greatest common factor is basically 1. So all I can do is take out a 1, which really doesn't change the problem at all. So there really isn't a greatest common factor because all we can take out is a 1. I do suggest, though, that you write the 1 on the outside. It's a good habit to get into for when we move on to the next section. So let's take a look at number 9. So for number 9, I noticed 1525, but there is a 1 there. So a lot of students see 1525 and they're like, oh yeah, I can take out a 5. Okay, but that third term also needs to be included, and you cannot take 5 out of 1. So really, you can't take out a 5 at all, and all you can take out in terms of numbers is a 1. So then I have x squared, x to the first, x to the first. So I can take out x to the first. And then I have y squared, y, and the last term doesn't have a y in it, so I can't take out any y's whatsoever. So all I can do is divide each of these by x. So 15 is going to stay the same. X squared divided by x to the first is x to the first, and then we're going to keep y squared. So then I'm going to keep the 25. X over x cancels, and then we get y. Now lastly, I have x over x. Now what I see a lot of students do is just cancel it out, say, oh, I'm done, I'm good to go. Okay, but think of numbers. 2 divided by 2 is 1. 6 divided by 6 is 1. So if everything cancels out, you don't just leave the term as 0. If everything in the term cancels out, you need to put in a 1. Any number, any letter, anything divided by itself is always going to be equal to 1. So you need to make sure that you have that 1 there. So that's your final answer. So let's take a look at number 10. So we need to figure out what divides 8, 6, 12, and 9. So if you think about it, there's actually nothing that divides them, so I can't take out a 1. So I have an a in this term, but I don't in this term. Okay, can't take out an a. I have an x in this term, but I don't in this term. So I can't take out an x. So this is one of those that doesn't really have a greatest common factor. But I do want you to be writing that 1 on the outside just to help you with that next lesson. So this right here concludes your note video for today, and thank you for listening.